For Lesson 31, we are studying ratios and proportions. This is an introduction to Unit 6 Proportional Reasoning, which is SOL 7.4. Our lesson objective today is to identify ratios and proportions that are formed by equivalent ratios. So a ratio is a comparison of two quantities. Our first example says we are looking at 4 buses for 240 students. So we are looking for two quantities. The two quantities we're comparing are our buses to our students. Okay, now if you remember from last year, when you studied ratios, you learned that ratios can be written in 3 different ways. They can be written with a colon, A to B. They can be written in word form, A to B, with the word to. Or they can be written as a fraction, A over B, which is also read A to B. For this unit and in 7th grade, our ratios will be written in the form of a fraction, A to B. So when we go back and we look at what we are comparing, the two parts that we're comparing are our buses, which will be part A, over or compared to our students, which in this case will be part B. So if we wrote that out with numerical form, we have 4 to 240, and that would be our ratio. Go ahead, pause the video, and copy this into your flipbook. For our next example, we have 12 basketballs for 3 players. So we have to identify what our two parts are that we are comparing. Again, we're comparing basketballs to players. So we're going to write down what those parts are just so it makes it easier in the future to remember what we're talking about and what we're comparing. So we have basketballs as our part A and players are our part B, excuse me. So we have 12 basketballs for 3 players. If we wanted to make this simplified, we can divide each of them by 3, and we would get 4 basketballs for every 1 player. You do not need to write this in your notebook. The next thing we want to look at are proportions. Proportions are ratios that are equivalent to each other. So they can be found by making equivalent denominators through multiplication. We have 4/12 is equivalent to 1/3. This was an example we just saw in our last example. 4/12 is equal to 1/3. We want to determine how we figured that out. So we look at our two denominators to see if they're equivalent to each other. My suggestion is to always start with your smallest denominator. In this case, that's 3. And seeing if there's any number you can multiply that denominator by to be equal to the other one. So 3 times what makes 12? Exactly, 4 does. Rules of multiplying fractions say whatever you do to one part, you have to do to the other part. Since we multiplied the bottom by 4, we now must multiply the top by 4. So 3 times 4 made 12. And now, does 1 times 4 make 4? In this case, it does. Yes. So these two ratios are equivalent to each other, so they are proportional. Pause and copy everything you see with the words and the example into your flipbook now. Okay, great. Now we're looking at example number 2 for proportions. One thing we need to understand is that all proportions are equal to each other if they are indeed proportional. If they are not equivalent to each other, then they are not proportional. So we are going to look at two ratios now to see if they make a proportion. Again, we're going to look at our denominators. So we're looking at 5 and 25. And we are determining can we make them equivalent to each other? And then will our numerators be equivalent to each other? So 5 times 25, 5 times what makes 25? Exactly, 5 times 5 does make 25. So does 8 times 5 make 40? You're right, it does. Yes. So these two ratios are indeed proportional to each other. In our next example, we have 2/9 and 20/45. So we want to know, is this a proportion? Are they proportional to each other? If they are, they will be equivalent to each other. So we're going to look at our smallest denominator, compare it to our larger one. 9 times what number will make 45? You're right, 5 does. So we must do the same thing to the top. 2 times 5, does that make 20? You're right, it does not. So in this case, no, they are not proportional. Again, you do not need to write this in your notebook unless you would like to. In our next example, we have 12/14 and we have 6/7. Our smallest denominator is 7. Does 7 easily become 14? Yes, by multiplying by 2. So therefore, if I do the same thing towards the top, 6 times 2, does that make 12? It does, yes. So these are proportional. Very good. And in our last example, we have 8/7 and we have 10/9. So we say, can 7 easily become 9? In this case, it would be a very weird number, not a friendly number, that would make 7 equivalent to 9. So in this case, what I'd rather do is make a common denominator by using cross multiplication, or what you may have heard in the past as butterfly multiply. We're going to take the bottom number, our denominator, and multiply it across towards the top. So 7 times 10, and that makes 70. Then we're going to take 9 times 8, 9 times 8, and that makes, very good, 72. Is 72 equivalent to 70? And actually our denominator, 9 times 7, is 63. Are these two ratios equivalent to each other? No, they are not. So these are not proportional. We will be exploring more with whether they are proportional or not proportional in the future. Proportional, excuse me. Very good. All right, now what I'd like for you to do is to create 6 boxes on the page next to your flip book, and label this page "You Try" and number the boxes 1 from 6. Pause the video to do this now. Great. For the "You Try" page, I want you to tell me if the following problems are proportional or not. All you have to do in your final answer is tell me yes or no. So I would like you to copy all of the problems into your notebook and make sure to show all of your work on the "You Try" page for problem number 1 and problem number 2.